Thank you. I needed one. So we can look on here and we can find constant of proportionality is K equals Y over X. Make sure you write this down. Why do you think I have you writing it down?
So we can use it to substitute values in.
And you won't forget. Good job. So I'm going to zoom out just, well, no, I'm gonna zoom back in. All right, find a dot, find a point, a dot, that is on a corner that looks like that. Can we find one?
15, 12.
15 and 12 is the one we're going to use because it is whole numbers and we don't want to guess what's in between, okay? So, what is my Y?
12. You said
12. Remember, not simplify, sorry.
Can't see.
Oh, sorry. Well, I gotta get it. There it goes, right there. All right, so our y-axis is 12. What is x? 15. Now, what do we need to do? Do we leave it like that?
No.
We're gonna simplify.
We could simplify this. What are we simplifying by?
Both can be divided by 3.
3. Good job. 12 divided by 3 is?
4.
And 15 divided by 3 is?
5.
Can I simplify it anymore?
No.
So our K is equal to 4/5. Can I write this in a different form?
Yes.
What else?
You can change it to a decimal.
Okay, what is my decimal?
8 tenths or 80 hundredths.
And is there another way?
80 hundredths.
Maybe 80%.
80%. Everybody good with that? There's 3 different ways to see this. All right, now let's go. Since we have our concept of proportionality, this thing is working for me. There we go. It's asking a question now. It says if Natasha attempted 30 free throws, how many would she probably make? First, use your graph to estimate the answer. Then verify your answer by using an equation. Okay? So we're going to use the graph. How can we use the graph to estimate our answer?
You can go where it says 30 free throws attempted and draw a line straight up and see where the line, the pink line goes through it. So you need to extend the pink line out.
Very good. Let's extend that out. All the way. And it would go right up here. Can't see, but
So we need to extend the Y too.
So we know it has to have more than
20.
20.
So more than 20 made. You can't see that. I should. 20 made free throws, correct? Now, how can we use an equation to solve this? We know we have free throws made. I'm gonna put free throws made. And then free throws attempted, correct? That goes with our concept of proportionality. So we can put our concept of proportionality 4/5. And what did they give us in the problem?
The attempted free throws.
The attempted. So is that your numerator or denominator?
Denominator.
Very good. So we're trying to find this one. What do we need to do? We know we gotta make our arrow go this way and this way.
Golden rule. Golden rule. What you do to the bottom, you do to the top.
Okay, so what are we doing to the bottom?
Times 6.
What are we doing to the top?
Times 6.
Good job. What is 4 times 6?
24.
So is that more than 20?
Absolutely.
Very good. 24 free throws made.
Okay, I got a question.
Yes.
Are they trying to get us to use the constant formula though? to use the equation, because it says to use an equation.
Y equals kx.
Yeah, so are we supposed to use y equals kx to solve that there? Because I know the kids are gonna wanna use proportions. Because that's what we've been doing since
And
last year.
they're used to it.
Yeah, so I think maybe on that, we can show them that way too, but then also revert back to y equals k times x, because that's what we're gonna have to use. So we
So
don't have to, but
instead of putting that, put y equals 4 over 5x,
Mm-hmm.
and then have them tell us.
substitute values in. So we know
Yeah.
that the y was the free throws made, right?
Yeah, so it'd be y is equal to 4/5.
Times
I
30.
think, I think I had that in my book.
Yeah, so then it'd be 4 times 30 is 120.
Over 5.
20 divided by 4, yeah. Just to maybe show them both.
Yeah.
Because here in a little bit, we're gonna be using an equation.
That's true.
And I mean, I did the same thing when I worked out though. I did the
The
proportion.
proportion.
And then I realized it's an equation and I was acting worked out that way. Because I was
Okay.
thinking like a kid. And if I was a student, I would do a proportion because that's what I'm comfortable with.
Yeah, same. That's why I did it here.
Okay.
But I had this one in there too, because I was
Yeah.
like, what if I was wrong down here? And I checked it anyway.
I like that. I like that you did the proportion because I felt I mean, that's what I did, so it's nice to see that you did the same thing.
Yeah. You want to?
All right, we're starting on page 146. Class, what's the title of the lesson?
Using an equation to create a table.
All right, so in the previous activity, what was discussed?
Using a graph to write an equation.
What do you notice is the same between the two titles?
Equation.
The word equation. So both equation can be changed to a table, equation can be changed to a graph. Again, this is different representations of proportional situations. All right, so take a moment and you're going to read over this intro right here, and maybe you can find some vocabulary that we haven't discussed this year.
Directly with the number.
Okay, you read it?
Varies directly is something that
Okay,
varies directly.
where did you, right here?
Yes.
Okay,
I'm not exactly sure what that means.
not sure exactly what that means. Okay,
Yeah.
great. Did we see any more vocabulary?
Proportional relationship
Okay,
is a
and
vocabulary.
highlight that for me, please.
Yes, ma'am. There you go.
All right. Anything else? Your choice. Anything else that you see? Okay, we'll stick with that.
Yeah.
Let's talk about the proportional relationship, because we just talked about a graph in the previous activity. What were the two things that we were left with knowing that if a graph was proportional?
Through the origin and a straight line.
That origin and that straight line.
Hopefully you know it's so straight.
All right, excellent. So, the words varies directly. Varies directly meaning dependent. Have we discussed this word before?
Yes.
Okay, very good. So it just means one depends on the other, or it can only vary. Oh goodness. Okay, so dependent and independent.
I learned that in 6th grade.
Good. Dependent. Okay, great. All right, so we have a situation here about somebody named Shayla, correct?
Yes.
All right, and we're also given a set of variables. Now, lately we've been seeing this thing with the k, the y divided by x, and then we'll turn that into y equals kx. Hopefully this is the one thing that we can sub in a number for, because this the y varies directly to whatever happens to the x to the constant. Okay, that's a lot of vocabulary said there, but we'll get through it. All right, so Shayla earns an amount of money for how many hours that she works. Everybody knows that if you don't work, do you get paid?
No.
Okay, and if you don't get paid, did you work?
No.
So they both go together. All right. So our job is to turn this into a table at the end, as well as still stating the constant of proportionality. In class, what variable do we use to represent the word constant?
K.
K.
Okay.
Yes, we know it starts with a C, but mathematically we use a K. All right. So it says her amount of money depends on how many hours she works. The equation describing this relationship is M equals $9.25 times hours. All right, so let me break that down. I think I just gave away what it was what.
Mm-hmm.
Okay, tell me about the M. It's a variable, and what is it gonna represent?
Y.
It's the amount of money.
It's her
That she
money,
makes.
her moolah. All right, gotta make that money. Now, what is the H?
Hours.
That is the hour. So let's make sure we understand that what each of those represent. So now the 9.25 doesn't have the dollar sign on it, but that's the amount of money that she makes per hour. That's a unit rate, remember?
Mhm.
So all of this stuff goes together again. So let me go back to constant, and I'm gonna abbreviate the other part of constant. OP, it also represents our unit rate. So we still got a lot of vocabulary coming out of this. Okay, so the constant of proportionality in this particular equation. Now, if we were talking about y equals kx or y divided by x equals k, well, which ideal up here, the m, which term, m 9.25 or h? Which one represents the constant?
$9.25.
Because of the exact same way that this is actually set up. This would be the y. You keep the constant in place, which is the k. And then this, of course, would represent your x. So that means don't get stuck on using or seeing x and y, because it can be changed out. All right. So now let's go on down to number 2. And our job is to take that information and we're going to turn it into a table. Now, we should be able to figure this part out right here, because if no hours were worked, how much money was earned?
Zero.
Zero. Okay, very good. But I'm going to use my constant. So it's a multiplicative relationship. So we're going to multiply no hours times $9.25. In class, we know anytime you multiply anything to zero, you're supposed to get zero. All right, and as you can see, this one has been skipped. Now on this side, it seems like we're gonna be multiplying everything down. So I'm gonna just go ahead and put that in here, because everything is multiplied by the constant. Now what's the opposite of multiplication?
Division.
This is what we're gonna be doing also, because sometimes this part is might have all the information to multiply, but sometimes you might have some other information which will allow you to divide. So if I don't have my number of hours worked, but I have my earnings, what can be done in the opposite to get to the other side?
You just divide.
I'm gonna divide by the same constant. Because either way, through division or multiplication, I should still get the same constant. All right, so I'm gonna set up my equation the way it's supposed to look. Y equals constant x. Better yet, we're using m is equal to, and we know our constant is $9.25, and the number of hours. So in this particular one, the $112.85 replaces which variable?
M.
The m. How do you know?
Because that's the amount owed, amount earned, that's the money.
M is the money.
Yeah.
Right, very good. So I'm gonna place it on this side. And at this point, this should now look like a one-step equation.
What we did for the warm-up.
What we did for the warm-up, very good. All right, the main thing is to isolate the variable h. This is 9.25 times h. What could I do to isolate my variable?
Inverse on
The inverse. What's the inverse of multiplication?
division.
Division. And we're gonna divide both sides by,
9.25. $9.25.
absolutely. And so then at this point, if we're working with calculators, I would ask the students, they can work it out on their calculators with the decimal. Okay, to start with. Now, I also added that I most likely wouldn't just do a automatic skip to a big number from 0 to 40. I would probably create a second table where we can do smaller terms and maybe develop a pattern first. So set up hours over here, money over here. And I would say, okay, we start off, of course, with 0, 0, and then what would happen with 1 hour?
$9.25.
Then we'll go up to 2 hours, $18.50, using smaller terms, and then eventually start doing the skip jump, where we would use the equation more, as well as the proportions maybe.
I liked how you wrote out the equation and then
Yeah.
substituted the y and the x.
Yeah.
So.
Okay.
Yeah.
And so we would probably work this more so out like this with the smaller terms. I cannot stop.
Yeah.